Alright, welcome back to part 2. So we're in the middle of proving that for any rational number and any irrational number, if the rational number is not 0, then the product of that rational number and irrational number is irrational. And we're doing this by a proof by contradiction. Alright, so we just made our assumption here, and now we're going to go ahead and plug in. So we know that x times y equals some number z, and we know is that x is rational and z is rational. So we're gonna go ahead and plug in. Well, first let's write our definition of rational. So remember, some number n is rational. And what that means is that there exists some a and b, and they have to be integers. And b cannot be 0. And if you take those and n equals a over b, then you know n is rational. So let's go ahead and we'll use a and b for x here. So we'll say x equals a over b, and we don't have a definition we can plug in for irrational numbers, so y is just going to stay y. And then we're going to know that z is also, so we'll just call z c and d here. So for some a, b, c, and d that are all integers, where our two denominators, b does not equal 0 and d does not equal 0. Okay, and we're able to do this by the definition of rational. Okay, so now let's just do some algebra and say that we're going to multiply both sides by b. So ay equals cb over d. Then we're going to divide both sides by a. So y equals cb over ad. Now, here's something. So we know that this numerator is an integer because integers are closed under multiplication. And we also know that this denominator is an integer because integers are closed under multiplication. So we have here the ratio of two integers. So this is starting to look very close to our definition of what a rational number is. So we're getting close here to showing that y is rational. Now there's one other part here that we need to take care of for our definition of rational. We need to show that whatever the denominator is, it's not 0. Now, we know that b is not 0 and d is not 0. So, so here we know d is not 0, but we don't really know about a. And so if we're just stuck here, we actually would not be able to say yet that y is rational. But if we look back here, we actually do know about a, right? Because we said this number x is not 0. Now, if x is a over b, then the only way that a could be 0, that would make x 0, and that's not possible. So we're going to use that assumption. All right.